Okay, this is the first one, so it's sine, okay? So A was -2, which means it's reflected. Your amplitude is still 2. So on all the graphs have like little parts to fill in, and then also obviously have to do the graph. For sine and cosine, it's going to ask you for the amplitude, the period, the phase shift, the vertical shift. If there's none, you just write none. But if there's one, obviously you have to include it. And then it's going to say to label the key points on your x-axis. So my amplitude is 2, the b was 1, so the period is 2 pi. And then that means we have our standard like 0, pi over 2, pi, 3 pi over 2, and 2 pi is our original key points. But then because there's something inside the parentheses, that means there's a phase shift. This would be to the right pi. So to each of my original key points, I added pi, and I got my 5 key points. Pi, 3 pi over 2, 2 pi, 5 pi over 2, and then 3 pi. And then mark them on the x-axis. And then because it's sine, we would normally start at 0 and go up to the amplitude. This time you're going down. So the original before the vertical shift went down to 2, up to 0, or down to -2. Up to 0, up to +2, back to 0. And that's what your graph looked like before the vertical shift. The vertical shift, which is up 1, I do at the very end. So I just took my curve and shifted it up 1. I said it last week, but I'll remind you, like, I'll take out colored pencils if you want to make sure you can, like, highlight which ones are your final answer. If you want to bring a highlighter, that's fine, too. Just realize a highlighter doesn't erase, right? But so you want to make sure you know what you're doing when you go to highlight it. That's the final answer. So you're either getting sine or cosine. So this is the cosine one. Your A is 2, which means your amplitude is 2. Your B is 2, which means the period is 2 pi over 2, which is pi. And that means your key points are 0, pi over 4, pi over 2, 3 pi over 4, and this is pi. And then I labeled those on the x-axis, 0, pi over 4, pi over 2, 3 pi over 4, and pi. There's no phase shift this time. There's a vertical shift down 1. Because it's cosine, I started at the amplitude, which was 2, came to 0, went to -2, back up to 0, back up to +2. And that's what the curve looked like without the vertical shift. Then we took it and shifted it down 1. So those points went here. Can you open the door for her, please? And that's your final curve. You'll get one of the tangent or cotangents. Cotangent and tangent are different, right? A is 3, but that's not your amplitude. It's not called an amplitude. It's just your A, which is how high the quarter point and low the 3/4 point go. The B is 1. The period is pi over B in tangent and cotangent. So this is just pi. And then we set what's in those parentheses equal to 0 and pi for cotangent. And I get my middle two asymptotes are at pi and at 2 pi. Those are the ones that are here and here. Then to the one on the left, I'm going to subtract the period. So I'd get x equals 0. And then on the one on the right, I'm going to add the period. I get x equals 3 pi. Those are your 4 asymptotes. So it's going to give you a line. It's going to say, what's your period? What's your asymptotes? And you're going to make sure you write them as an x equals because they are lines. So it is x equals 0, pi, 2 pi, and 3 pi. You can write them each out separate, x equals 0, x equals pi, x equals 2 pi, x equals 3 pi. Or you can just list it like that, but you have to have the x equals because they're lines. So then those went on the graph. That's where these asymptotes came from. And then for cotangent and tangent, you have to find the 0, which is the halfway point between your two asymptotes. This is at pi over 2, 3 pi over 2, 5 pi over 2. Sometimes it's obvious, and you can just cut the distance in half. Sometimes it's less obvious. You have to add the two asymptotes, divide by 2. So there will also be a line for zeros, and that you will give me, you don't need to write x equals. You can. It's not wrong. But you could just give me those 3. So you should have 4 asymptotes, 3 zeros. And then because it's cotangent, I'm going to eyeball the quarter and the 3 quarter points and go up on the left for the 1 quarter and down to the right on the 3 quarter. And I'm going to A, which is 3. And then connect your points to make your curves. Tangent. Again, you're getting one of cotangent or tangent, so you got to be prepared for both. So A is -2. We don't have an amplitude for tan or cotangent, but that A is how high and low my little quarter point and 3/4 point goes. So now for tan, we take what's next to tan in those parentheses, and we set it equal to negative pi over 2 and positive pi over 2, and we solve for x. So those first asymptotes are x equals pi over 4 and x equals 3 pi over 4. Then our period, because b is 2, our period is pi over 2. So from the smaller one, which is the first one I found, I subtract the pi over 2, I get negative pi over 4. From the bigger one, the second one you found, I added pi over 2 and get 5 pi over 4. So now my other asymptotes, starting from left to right, the first one is x equals negative pi over 4, then positive pi over 4, then 3 pi over 4, then 5 pi over 4. Those are where the asymptotes go. Then we need an exact point halfway between. So halfway between negative pi over 2 and positive pi over 2, pi over 4 was a little bit easy, right? That's 0. And then between pi over 4, 3 pi over 4 is pi over 2, 3 pi over 4, 5 pi over 4 is pi. Those are your zeros, which again, there'll be a line that says, what are your zeros? And you'll write them out. 0, pi over 2, and pi. And then you're eyeballing the quarter and the 3/4, the quarter and the 3/4. Tangent typically goes up to the right and down to the left, but because it's a -2, it flips upside down. Questions on it? Yeah.
Are we going to have to mark the points in between?
Yeah, the zeros. The quarter point and 3/4 you eyeball, but the zeros, yeah. 1, you'll mark them here, but also there is a line that's going to ask for them, which is worth points. Yeah.
If there's like a negative, you have to like do it as there's like cotangent, right?
The shape of a cotangent, yep. Yeah, the asymptotes will be different, but the shape is the same.
Okay. I'm confused as to like what the amplitude does.
It's just the quarter point that you mark the A.
Oh, okay.
And the 3/4 point you mark the negative A, or vice versa. If it was positive tangent, that's reverse.
Okay.
So it makes it stretch, right? Like the higher that number, the higher I'm going, which makes it skinny, it's a vertical stretch. It makes it stretch.
Okay.
Yep. Carly.
Could they be shifted vertically?
Yeah. So if I said +1 after, everything goes up 1. But I find the asymptotes and I find all this stuff, then I shift it up. Yep. Okay. Yeah. Where did I get it? That's the one. So when I set it equal to negative pi over 2 and positive pi over 2, the negative pi over 2 one is pi over 4. Then you subtract the period. So the first two you find for tangent, what you get from equal to negative pi over 2, what you get from positive pi over 2, those are the middle asymptotes. And then from the first one, you're going to subtract the period. So when I subtracted pi over 2, that's this over here. That's where I got negative pi over 4. So this was pi over 4, which I got from setting it equal to negative pi over 2, and then I subtracted the period. So first ones you're setting equal to negative pi over 2 and positive pi over 2, and those are the middle asymptotes, which are pi over 4 and 3 pi over 4. And then for the smaller one, you're going to subtract the period. So I would go left. And then the bigger one, you're going to add the period. So you go right. Okay, then came cosecant. Yeah.
I have a question as to
Cosecant and secant. So remember, you're getting, like if I give you sine, you're getting secant. So it will make you graph sine, and then it will make you graph cosine, and then secant. If not, if you're getting cosine, then you're getting cosecant, because it will make you graph both. So this says cosecant, which means I graph sine. My A was -2 upside down. My amplitude is 2. My B is 1/2, which makes the period 2 pi over 1/2 or 4 pi. There's a phase shift to the right, pi over 2, or 2 pi, sorry. I got that by setting this equal to 0 and solving it. And there's no vertical shift. So then once I got the period, which was 4 pi, I multiplied times the fourth, a half, 3/4, and then the last one's the period. So my initial key points without the shift were 0, pi, 2 pi, 3 pi, 4 pi. But then we had to shift it to the right, 2 pi. So now I add 2 pi, 2 pi, 2 pi, 2 pi, and now I get my final key points at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So that's where I marked 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, right? I started there. And then it was a negative sign. So I normally start at 0 and go up, but I went down to 2, up to 0, up to +2, back down to 0. And this was the original sine curve. We need 4 asymptotes. So I continued the curve to the right, 1 more to get another asymptote. And I continued the curve to the left, 1 more to get another asymptote. I don't care which direction you go. You can go 1 full curve to the right, 1 full curve to the left. Doesn't matter. As long as at the end you end up with 4 asymptotes. So now I've got everywhere there's a 0 on sine became an asymptote. So you only need 4 of these 5, but you could go in either direction, okay? And then everywhere there was a max, I bounced the parabolas up. And everywhere there's a min, I bounce the parabolas down. So again, 4 asymptotes, 3 curves. You only needed 3 of those curves and 4 of those asymptotes, but you could go either way with sine. I could either go forward and eyeball it, or I could go backwards and eyeball it.
So you need 3 curves.
You need 3 curves. So everything that has an asymptote, tangent, cotangent, secant, cosecant, 4 asymptotes.
Wait, so because you continued it after.
Right, because you could go this way or you could go that way.
Okay.
So you could have gone this way and not drawn this, or you could have gone this way and not drawn that.
Okay.
All right, I'm just going to go the last one, which was secant. So now it's secant, which means we're graphing cosine. 3 is your A and your amplitude. B is pi over 2, so the period is 2 pi over pi over 2. Keep, change, flip that, and that means your period's 4. So your initial key points are 0, 1, 2, 3, and 4. There's no phase shift, but there is a vertical shift down. So after you find your key points, you're going to plot those on the graph. That's 0, 1, 2, 3, 4. And it's cosine with 3 as its amplitude. So you're starting at 3. You're going to 0, negative 3, 0, positive 3. This is this one. That's my original cosine curve. That only gets you 2 asymptotes. But for cosine, the easiest thing to do is just drop a little half and a little half to the right and to the left to get the other ones. So I'm going this way. I'm going this way. Then everywhere there's a 0 is my vertical asymptote. And this, because there's a vertical shift before I drew my curves, you could wait till after you draw your curves, but at some point we have to shift everything down 1. So the shift down 1 became the yellow curve here. And then I bounce the parabolas off of the max and the min of the yellow curve. So I found the key points, drew the asymptotes, then did the vertical shift. You don't want to try to figure out your vertical shift or your asymptotes after you do the vertical shift. It's harder to see the midline. Questions on that one? So good chunk of points come from these graphs, which is why we spend most of the time on it, but it doesn't mean it's all graphs. If the well, you don't have to move the asymptote. You're moving the curve, you mean. You mean if your amplitude is a fraction? Yeah. So just like if it's a half, you're going up to 1.5. Or you're going down to negative a half. Like just, it doesn't have to be perfect, but you can mark it. Yeah. Last slide, it has multiple different scales. I was trying to like put a couple of combination things together because there's obviously a lot more content on here than just the graphs. So sine -1 of cosine 16 pi over 3. This is your compound, so we're working inside out. We go inside, the cosine, I changed it to 15, right? No, I made it 16. At 16 pi over 3, I take that 16 pi over 3, I make it a mixed number, which is 5 1/3. And then I use my even odd trick. Oh, I didn't do the top one, sorry. The odd is on the left, which means cosine of 5 would have been on the left, and then 1/3 is less than a half, which means it's in the first quadrant after the odd, which means it's in quadrant 3. So it's a negative cosine. It's an over 3. Cosine is 1/2. So my cosine at 16 pi over 3 is negative 1/2. And then you're doing sine -1 of negative 1/2. So we hopefully remember that sine and tan come from the right-hand sides of our graph, which would be negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6. And then 0, pi over 6, pi over 4, pi over 3, pi over 2. Well, sine is negative 1/2. You're looking for where the y is negative 1/2 at negative pi over 6. So this is the ending answer, okay? For 9, this is not a unit circle-based fraction, so we set up a triangle. Tan is opposite over adjacent, so I made the opposite side 24, the adjacent side 7. This is a triple, 7, 24, 25, so I knew the hypotenuse was 25. And then the secant is the reciprocal of cosine, this is switch. This is the reciprocal of cosine, so this would be hypotenuse over adjacent. So this should be 7. That should be 7, okay? Okay, and then arc length, okay, R is 6, and theta, I gave you 135 degrees. You have to convert it into radians. 135 is 3 pi over 4, multiply that times 6, and you get 9 pi over 2. That would be kept exact. I'm going to go back up to the top. These are your even odd functions. So which are the ones you don't change? Cosine and secant, right? It's reciprocal functions. So if I said secant of t was 1/3, then secant of negative t would still be a positive 1/3. And then cosine of that same angle is just the reciprocal. So it'd be 3. Sine, cosine, tangent, sine, cosecant, tangent, cotangent, you change the sign. You sure? I'm going to start us in 3 minutes.